Hi, Assalamualaikum. I'm Muhammad Kamil bin Samsudin. Today I'm going to present about the thermal radiations. So, the thermal radiations is a form of radiations that emitted by the bodies because of the heat temperature. As we know, it differs from the other forms such as electromagnetic wave, and then the radio and TV wave, microwave, thermal and infrared radiations, X-rays, and for the last is the gamma rays, because they are not related to the temperature. Alright, next I'm going to talk about the type of magnetic radiation. The electromagnetic radiations is applicable to heat transfer because it is emitted of a form of energy. So now I'm going to say about the temperature. The temperature is measure of the strength of this activity at the microscopic level. So different microscopic level, it will produce different different type of wave. So as we know, the temperature will be emitted when under the absolute temperature, such as when the temperature is more than 0 degrees Celsius, it will emit the thermal radiation. Because when we know, right, so the temperature has less than that, it will not produce the thermal radiation. So the example of thermal radiation will be produced is when we are moving, so we are going to produce heat. So that part of the thermal radiations. So now I'm going to explain different electromagnetic wave spectrum based on the wave. So it will start from the what we call the wave, radio and TV wave. It starts from 10 power of 10. We are using the unit micrometer, from 10 power to 10 to 5. So next, for microwave, it will start from 10 power of 5 to 10 power of 2. For the thermal and infrared radiations, it will start from 2 till negative 10 power of negative 1. While for X-rays, it will begin from 10 power of negative 1 till 10 power of negative 4. For the last, for the gamma rays, it will represent from 10 power of negative 4 till 10 power of negative 7. For this part, we are going to learn, we are not going to touch about cosmic rays, because cosmic rays are quite, it have very small wavelength. So I think that's all from me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh, and a very good day. Today I am Muhammad Fazli from the Zulkifli, who would like to explain about radiation heat transfer. So, radiation heat transfer, unlike conduction and convection, it does not require the presence of material medium to take place. So, basically, electromagnetic wave or electromagnetic radiation represent the energy emitted by the metal as a result of the changes in the electronic configuration of the atom or the molecule. So I would like to take an example. If a person stands near a campfire, so radiation heat transfer can occur between two bodies separated by a medium colder than both bodies. So for example, if the person stand near the fire, so between the person have air. So because the air is very cold, a little bit cold between fire and the person, so the radiation heat transfer can still occur between the person and the fire. Thank you.
Okay, now that's out of the way. Let's focus on why this video is made of. That is its properties of radiation. But before we dive into the subject, we have to know what is properties. What is the meaning of the properties? Well, to put it simply, properties is a different attribute of characteristic or a different quality of thing. What I mean by this, for example, there is a phenomenon, different phenomenon that we can observe, such as raining and sunny day. What can we tell between these two different weather. The difference between those two weather is that when sunny day, the sky is much more clear and the temperature is much more higher than when it's rainy day. Because when it's raining, we all can tell that it's more darker, more cloudier than usual, and things get wet, such as the road and the car and whatsoever. Okay, now we understand what property is. Let's move on to the properties of the radiation. What is the meaning of the property of radiation? Well, the meaning is that when radiation strike a surface, a portion that enter the surface, some of it absorbed by the material, and the remaining of the radiation is transmitted through. Okay, based on the diagram, incident radiation is let's for example from the sun emanates on the surface. A part of it will reflect the reflection, whereas the reflection, the symbol for reflection is rho, and a part of the radiation will be absorbed. The symbol will be represented as alpha. The portion that has been transmitted, and the symbol is tau. There is many wavelengths that we have known, but there are three considered to be dangerous. The main three is gamma ray, ultraviolet, and last but not least X-ray. That's three considered to be dangerous because once if too many wavelengths affected on our skin, it will cause a disease such as a cancer or other stuff such as heat stroke. Conduction and convection usually require a medium to perform heat transfer, but this does not affect radiation whatsoever because radiation does not require medium to perform heat transfer. In fact, radiation performs even more effectively without medium.
So now we will be moving to the concept of absorptivity, reflectivity and transmissivity. So what is absorptivity? Absorptivity is the amount of absorbed radiation per incident radiation, which can be denoted by G absorption over G incident. Meanwhile, transmissivity is the amount of transmit radiation per incident radiation, which can be denoted by G transmission over G incident. Reflectivity is the amount of reflect radiation per amount of incident radiation, which can be denoted by G reflection over G incident. Different case from absorptivity and transmissivity. Reflectivity depends on the direction of the incident radiation itself and the surface types of the incident radiation encountered. The type of surface are smooth surface and rough surface. Practically speaking, the two types of surfaces, which are smooth and rough, will produce different reflection outcome. For rough surface, it can be assumed that the reflection is in a perfectly diffuse reflection. This means it will reflect equally in all directions. For smooth surface, it can be assumed that the reflection is in a perfectly specular reflection. According to the first law of thermodynamics, the sum of absorption, reflection and transmission radiation is equal to incident radiation. This can be denoted by G absorption plus G reflection plus G transmission, which is equal to G incident. To obtain new relationship, we must divide all with G incident. So, we'll be gaining a new relationship which is alpha plus rho plus tau, which is equal to 1. Different case for opaque object, the relationship is not the same as the normal one. For opaque object, transmissivity is equal to 0. So in the relationship, there is no tau. So the new relationship will be alpha plus rho, which is equal to 1.
Hi guys, on this section we're gonna explain you guys about black body radiation concept. Before we begin, we first have to understand and absorb the concept of radiation, what is meant by radiation. Before we go through, we need to know that all bodies who has the temperature below absolute zero will emit thermal radiation. So this means that all objects in the world will emit a thermal radiation. So to define a black body, a maximum amount of radiation will be emitted by a surface at a given temperature. So this means a black body will absorb all radiation at all wavelengths. For a further explanation about black body, we're making you guys a short clip about how does a black body behave in certain conditions. The opening on the box, which can absorb all the rays of light incident on it, will appear to be black. For this reason, a body which absorbs all the rays falling on it is known as a black body. However, if it continuously absorbing energy in this way, the temperature would increase infinitely. In fact, a black body that remains at constant temperature is absorbing and emitting the same amount of energy. If we compare a black body with another body, which appears to be a gray body, at the same temperature, the amount of energy emitted by the black body would be higher. If we consider a constant box with a hole in it, we find that the opening will absorb more radiation than the external wall. If we keep heating the box with higher temperature, the tungsten box will start to emitting electromagnetic waves with a different wavelength and energy. At this moment, the opening will emit more energy than the walls, hence it will be seen brighter than the walls.
Now I want to move on to the amount of radiation at a surface, the energy emitted from a surface to a certain wavelength that depend on three main conditions. First is the material of the body. Second, the surface condition. The third is the surface temperature.
In contrast with a black body, there is a gray body. So what does it mean by a gray body? For a simple explanation, a gray body is a real object, or we can say a real surface that has a total emissive power less than that of a black body. So this means a gray body, or easily we can say any real object that has a surface, will emit less radiation compared to a black body.
Jackpot an Bord, will von hier über London direkt nach New York. Denn ab heute lebe ich jeden Tag, als ob ich morgen tot wäre. Laufe durch den Park und werf mit Geld, als ob es Brot wäre. werden und sie will Pelz tragen und sie will schnell fahren, einmal um die Welt fahren. Sie kann sich kaufen, was sie wollte, doch nie hatte, denn ich hab jetzt die American Express und zwar die schwarze. Also komm, Baby, bitte mach dir nie mehr Sorgen um Geld, gib mir nur deine Hand, ich kauf dir morgen die Welt. Egal wohin du willst, wir fliegen um die Welt. Hau sofort wieder ab, wenn es dir hier nicht gefällt. Baby, bitte mach dir nie mehr Sorgen um Geld.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farhan bin Muhammad Fairuz. So I will continue to the next subtopic, which is view factor in radiation for various geometries. The view factor. View factor is defined to account for the effect of orientation on radiation heat transfer between two surfaces. A view factor also can be defined as a purely geometric quantity and is independent on the surface properties. View factor, also known as configuration factors, form factors, angle factor, and the last one, shape factor. Okay. For second one is self-viewing surface. Self-viewing surface can be defined as the fraction of radiation viewing surface A that strikes itself directly. We have three surfaces of self-viewing surface, which is plane surface, convex surface, and concave surface. For the plane surface and convex surface, F or viewing factor A strike A equal to 0, and the last one is concave surface F A viewing factor F A strike to A greater than 0. For example, there are two spheres, inner sphere and outer sphere. The inner sphere we mark it as 1 and the outer sphere is 2. The formula is like F12. Since the radiation leaving the surface of smaller sphere will be intercepted by larger sphere, the view factor could be F12 equal to 1. So we move to reciprocity relations. So what is the reciprocity relation? The reciprocity theorem for V factors allows one to calculate FBA if one already knows FAB. So the formula is like AA FAB and equal to AB FBA. In radiation analysis, we usually form an enclosure. The conservation of energy principle requires that the entire radiation leaving any surface A of an enclosure be intercepted by the surfaces of the enclosure. So we have F11 plus F12 plus F13 equal to 1. So this is the formula for the summation rules. Before we continue,
let's recap what is the symbol represent in each formula. Next, radiation heat transfer. The analysis of radiation exchange between surfaces is complicated because of reflection. This can be simplified when surfaces are assumed to be black surfaces. So the symbol Q in this formula is referred to heat transfer rate. After applying reciprocity, we will get the formula Qij equal to AI Fij multiplied with Stephen-Boltzmann constant multiplied with Ti to the power of 4 minus Tj to the power of 4. So this is the formula for radiation heat transfer black surfaces.
So there are various geometries. The first one is small object in large cavity, and then next infinitely large parallel plates. The third one is infinitely long concentric cylinders, and the lastly is concentric surface.
Okay, firstly, let's focus on small convex object in a large cavity. According to picture, the small object we can mark it as 2, while the large cavity we can mark it as 1. Okay, for the formula. So the formula is like this. Q, which is heat transfer rate, equal to emissivity of surface 1 multiply with Stephen-Boltzmann constant multiply with difference of temperature, which is T1 to the power of 4 minus T2 to the power of 4, and then we can get the Q12. Then for two large infinite plates, based on the diagram, we can see two parallel plates that have already marked as 1 and 2. Okay, for the formula, so we can use the formula of Q equal to Stephen-Boltzmann constant multiplied with T1 to the power of 4 minus T2 to the power of 4, and divide by 1 of emissivity of surface 1 plus 1 over emissivity of surface 2 minus 1. The third one is infinitely long concentric cylinder. So we have two radius here, which are R1 and R2. So how to find the heat transfer rate? We can use this formula. We can use the formula given, which is Q12 equal to area of surface 1 multiplied with Stephen-Boltzmann constant multiplied with change of T1 to the power of 4 minus T2 to the power of 4 divided by 1 over emissivity of surface 1 plus 1 minus emissivity of surface 2 over emissivity of surface 2 also, then multiply in bracket of R1 over R2. And lastly is concentric spheres. Okay, for this diagram, we also have two radius, which are R1 and R2. A ratio can be made, which is A1 over A2 equal to R1 to the power of 2 over R2 to the power of 2. And then we also can calculate the heat transfer rate by using the formula given. Okay, that's all for this subtopic. We continue with subtopic 1.5.
Assalamualaikum. My name is Muhammad Farid bin Muhammad Fauzi, and today I will explain about the calculation of radiation shield.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Asram bin Manasi, and I'm going to talk about radiation shield. So, radiation shield is the protection of people from harmful effects of exposure to radiation.
Radiation heat transfer between two surfaces can be reduced greatly by inserting a thin high reflectivity sheet of material
which is the radiation shield between the two surfaces. Radiation heat transfer between two large parallel plates of MCT, the first MCT and the second MCT, maintained at the uniform temperature. Okay, this diagram shows the placement of radiation shield in the surface. Firstly, at the left is the inner surface, which is the first surface, and the right is the second surface, while the shield is placed in the middle of the surface. Okay. For the calculation of rate of radiation heat transfer, which is based on this formula, whereas E is the Stephen-Boltzmann radiation energy, the first surface and the second surface. While the lower part of this formula shows the resistance of each layer, which is this is the first layer here, and then here is the second one, which the area between the first surface and the shield, and then these two is the surface resistance of the shield, which is here, and then proceed with the resistance, the distance between both shield and second plate, and then lastly is the resistance of the second plate, which is the outer plate.
So this is the types of radiation and shielding. First, alpha particles can be stopped or shielded by a sheet of paper or the outer layer of skin. Next is beta particles that can pass through an inch of water or human flesh, and also can be effectively shielded with a sheet of aluminium 1/25 of an inch thick. Gamma rays can pass through the human body like X-rays, and dense materials such as concrete and plumbum can provide shielding. So this is the factors that affect radiation dose. Regulation and procedures have been developed and implemented to limit radiation dose by regulating the use, storage, transport and disposal of radioactive material by controlling time, distance and shielding. So first, the time. Short the time spent near the source, the smaller the dose. Secondly, is distance. The greater the distance, the smaller the dose. And lastly is shielding. The materials that absorb the radiation dose.
And then lastly, for this final part is the formula of the radiation shield, which is the previous one is the long one. Then the formula can be simplified, which is this factor is the same as 1, while the area of the surface is same. The first layer, the second layer and also the shield layer is same surface area. Thus provide us with this formula which is area time with emissivity and the minus of the both temperature, final and the initial. And then here is the part where no shield resistance is the resistance of no shield, while here is the resistance of shield.